Hello, good morning, students. Today, another important question for the plus 2 physics, that is Doppler effect in sound. First of all, you have to know the definition of Doppler effect. See, Doppler effect means the definition is the apparent change in the frequency due to relative motion between source of sound and observer is called Doppler effect, and the shift in the frequency is called Doppler shift. That is a definition of Doppler effect and also Doppler shift also. So the best example for this will be, let us assume that you are standing on a railway station platform when the train is coming towards you by whistling. So when it is coming towards you, the sound increases, the frequency of sound will be increases. When it is near you, when it is at your point, the sound will be maximum. When it is moving away from you, the frequency sound will be reducing, decreasing, the frequency of the sound will be decreasing. That means actually what is happening here, the frequency of the sound is constant, but when it is moving, it will changes. We can observe that it is changing. That apparent means which can easy to visualize or easy to hear. So that apparent change we observe by the observer, that frequency change you can call it as the apparent change in frequency. That effect you can call it as the Doppler effect. The shift in the frequency you can call it as the Doppler shift. That's all. So for this explanation, if it is asked for the long answer question, you do one thing, better to derive the apparent frequency. So this is an easy method, it is the oldest method. Okay, very easy to hear, easy to observe, so easy to understand. So that is, first of all, derivation for an apparent change in the frequency. Let us say the apparent change in frequency represented with the symbol of n dash. Okay, n is the frequency, n dash is the apparent change in frequency. Here if you observe this diagram, let us say S is the source here present, O is the observer, both are moving in the right side direction. That means that can be represented by this arrow mark. Okay, that is in the positive x direction. Okay, let us see. Now source is moving with the velocity vs and observer moving with the velocity v0. So comparing with the source, it will moving very slowly, dead slowly, let us say. Okay, now source, from the source produces a sound of velocity v. So that can be heard by the observer O in time, let us say 1 by n second. Okay, in time is 1 by n second. Then as you know that velocity is there, time is there, so in place of t seconds we can write 1 by n. Why? Because n is represents the frequency. So then the distance between these two is nothing but velocity into time. That means simply you can write v into 1 by n, that is v by n. So in that time it is very less moving. In that time source move from S to S dash. In what time? In same time, 1 by n second only. In that time source move from S to S dash. Then we can say that the distance traveled by the source is, you can say as usual, velocity is vs, time is same 1 by n second. Then the distance between them you can call it as the vs by n. Now present source is at S dash, observer is at O only. Let us say why, because it is moving very slowly. Here I am considering the position will be not changed. Let us say small change will be there, that is negligible, you can say. That means now present position of the observer is at O, source is at S dash. This distance you can call as the apparent wavelength. Apparent wavelength you can call, represented by the symbol of lambda dash. Let us see the written part. Now same thing here I am explained just now. Let us consider source is at S, observer is at O, moving with velocities Vs and V0, and V is the velocity of sound. Okay, now source S moves from S to S dash in time 1 by n second. Then the distance traveled is SS dash, which is equal to velocity into time, that is Vs into 1 by n. Simply you can write Vs by n. Now here when source S produces a sound, okay, of velocity v, that can be heard by the observer in 1 by n second. Then the distance between them is, you can say, SO, which is equal to V into velocity into time, that is 1 by n, that is V by n. So we will get the Vs by n and V by n. So total distance we will get V by n. This travel distance is Vs by n. Now we have to find the apparent wavelength. So apparent wavelength represented by the lambda dash, which is equal to S dash O. So S dash O means SO minus SS dash. You will get S dash O. Same I am right here. Lambda dash is equal to S dash O, which is equal to SO minus SS dash, which is equal to, you can say, this distance, that is V by n minus Vs by n. Simply n is the common, so we can write V minus Vs by n. Next, what you have to find? Apparent change in the frequency have to find. Okay. Sorry, yeah, mistaken. Apparent wavelength is equal to lambda dash is equal to S dash O is equal to SO minus SS dash V minus Vs by n. Okay. Now, the apparent change in frequency, which is equal to, we can say, n dash, that is relative velocity with respect to the observer by apparent change in wavelength, that is lambda dash. Simply relative velocity of the observer, how much? Velocity of sound is V. If the velocity of the observer is V naught, then relative velocity between these two is nothing but V minus V naught or V0 by lambda dash. As you know that lambda dash is equal to V minus Vs by n. Substituting you will get, so take out the top side, V minus V0 by V minus Vs into n. So therefore finally I wrote apparent change in frequency n dash is equal to V minus V0 by V minus Vs into n. Here the terms meaning is n dash apparent change in frequency, n is the fundamental frequency, okay, V is the velocity of sound, V naught is the velocity of the observer, Vs is the velocity of the source. Depending on their source observer conditions, the changes will be occurred in this formula in the simple way. So I will explain this. Now let us see the case 1. Source is in motion, observer is at rest. Source motion, observer rest. In this you can apply again two parts. Part number 1, when the source is moving towards stationary observer. Here you can say that stationary observer means velocity of the observer is 0. Source is moving towards observer, that means arrow mark will be in the right side direction. You can say velocity of source is equal to simply plus Vs only. Then what happened to the apparent change in frequency? As you know that apparent change in frequency n dash is equal to, the formula is V minus V0 by V minus Vs into n. This is the formula. Now substitute the values here. What you will get? N dash is equal to V0. This is value 0. There will be V by V minus Vs into n. That means denominator is less. That means here n dash is greater than n. That means apparent frequency is more than the natural frequency. That is the A. Next, in the B case, in place of two words you can use away from. So you can say when source is moving away from stationary observer. Again write the line. This is the source, this is the observer is at rest, source is velocity moving away, that means in this direction, that is you can say velocity is minus Vs, negative axis. Then you can say directly I am substituting here, you can get n dash is equal to, this is the one, substituting the values you will get V by V plus Vs, minus of minus Vs, V plus Vs into n. So denominator is more, that means n dash is less than n. This is the case 1. Okay. Next, case 2. So we can get the case 2. So what is the case 2? Observer is in motion, source is at rest. That means we can say source is at rest, observer in motion. Okay. Now in the again case 1. So we can say that source is at rest. Put a line here again. Put a line. This is the source. This is the observer. Don't change the positions. It will so source is at rest. That means velocity of the source always 0. Now in this case, when the observer is moving away from the source, so that means you can say when observer moving away from stationary source. Okay, this is the A condition. So velocity of the observer is Vs is equal to V0 is equal to this moving in the away, that is positive direction, that means simply V0 only, plus V0 only. Okay, now as you know that apparent change in frequency, the formula is apparent change in frequency n dash is equal to, as using the formula, V minus V0 by V minus Vs into n is the formula. Vs is equal to 0, so this is the positive only. Then we will get apparent change in frequency V minus V0 by V into n. That means denominator is more value, numerator is V minus less value. Then we will get n dash is less than n. That is apparent frequency is less than the original frequency, fundamental frequency. Next, in this case B, when observer moving here away, here is towards from stationary source. Again put the line, source, observer. So this is 0 velocity, this is moving towards, that means negative direction, that is you can say minus V0. Then substituting in the same equation, n dash is equal to, will get V minus of minus, that is plus V0 by V into n. So numerator is more less, that is apparent change in frequency, so will get more than the original frequency. So these are about the conditions for the Doppler effect, and two parts, two conditions you can observe here. So this is one, yeah, source, observer. Okay, case 2, source, observer, motion. This is condition 1. Okay, thank you for watching. All the best for exams.